talk about conic sections. Basically, it boils down to 2, 3, 4, 5, 6. I don't think this is a section. What's that? Yes. So we're going to talk about parabolas, then we'll talk about circles, then we'll talk about ellipses. Is that 2 L's? Is that right? Did you see me to spell that correctly? And then hyperbolas. So those are going to be the 4 conic sections that we will look at. Each conic section has its own, what you say, a generic formula for looking at them. Each one of them will spend, usually parabolas and circles take us maybe a day and a half to get through. That's why I'm saying tomorrow we're going to look at circles, which you guys have all done. You guys all know how to write the equation of a circle. Well, it's okay. We'll do a quick refresher tomorrow. It's real fast. The other thing that I do with circles is I still will talk about writing the equation of the line that's tangent, little things like that. So we'll do a little bit of equation work like that. Next week will be the newer things, ellipses and hyperbolas. Ellipses are basically ovals, and hyperbolas are the parabolas that are double parabolas. Okay, so that's what those look like. My best guess is that normally, sometimes I throw a short quiz before we do shifting, where it's a lot of identify parts type things, like what's the vertex, what's the focus, that kind of thing. It's usually pretty simple when it starts getting non-shifted. Write a couple of equations, because it's all procedural at that point. And then after we start going through all the standardized things, then we automatically switch to shifting them. And like I was saying, that's your horizontal and your vertical movements of everything. So we'll do that, and then we also write equations. This usually takes us about 2 weeks or so to get through. So if we're thinking about calendar-wise, I can get what in work. Yeah, that'll be next week. I'm guessing around that first Friday-ish of November. Someone, oh wait, no, these are half days here, aren't they? One of those days is a half day for parent-teacher conference prep thing. But whatever, we'll figure it out. Yeah, right. I see what you did there. You just didn't mean to do that. What's that? Yeah, there's a lot of weird ones coming up. Okay, so let's talk about parabolas. Now, what I don't want you to do is write all this out, but for right now, we know that we have an equation y equals ax squared. And we've been working with that value for so long. What happens now that within a parabola, there are actual parts that you did not know that existed. What happens here is that every parabola has some sort of a vertex. Okay? Now, parabolas can open up or down, and they can actually move left or right depending upon what's going on, and we'll explain that here in a second. We all know that a basic, boring parabola, y equals ax squared, has some vertex here. Today, all of our vertices will be centered at the origin to make our lives easy, right? So we understand how things work. Now, when you start to think about how parabolas open up wide or narrower. The wider it opens up, that means the smaller the a value is. The closer the absolute value is to 0. Like a 1/2 would be a wider one than 2. Does that make sense? Now, also that a value, if it's positive, it means it's up like a cup, or down at the front if it's negative. Nothing too crazy. Now, when it starts to get into these things with conic sections, it really starts to become more of the thing that you actually can, that makes a little bit of sense. When you think about a vertex, vertices always look at what's called a focus. There's always some focus value that a vertex looks at. Okay? That focus, if you think about your eyes focus on an image, right? It passes through the spot, what is it, cornea, I think? Goes through the cornea and it focuses at something and it bounces back to something in the back of your brain. I didn't do very well at biology. Yeah, I dropped out. I actually dropped AP Bio my senior year since through this. Okay. Also, behind every vertex in a parabola, there's going to be an imaginary line called a directrix. Now, this would be a bad idea to have this information here. So this is going to be a focus, a vertex, and a directrix. And again, like you were just saying, what I say about the eye, how does it work? Where what's in the middle of the eye? It's the retina. It focuses at something. What's behind it? The retina's behind it. All right. So your cornea. Here, I'm like, you guys can see my eye, right? Don't shoot. Can you see the whites of their eyes? So if you think of an eyeball, or you think of the lenses on your glasses, the lenses on your glasses are all curves. They're all conic sections. These are all conic sections of curvature to help allow your focus value to fit your eyesight. Okay? It's the same idea as a contact. A contact is a parabola. I know I should have changed mine today. Mine really bad. What's that? Torics, right? Yep. Yep, I have toric lenses as well. So here's what's going to happen. When we start talking about parabolas in terms of conic sections, we're always going to have a vertex, a focus, and a directrix. Okay? Now, depending upon how the parabola opens, will tell us specific values. Here's the one thing. The distance between the focus and the vertex is always going to be the same as the vertex to the directrix. Those two distances will always be equal. They have to be. That's how it stays balanced. Okay? If it doesn't do that, that means your eyes are out of focus. That's why we need prescription lenses to help balance the focal point on your eyesight. That's where all of this comes from. This is optometry. So if you start thinking about the different versions of parabolas, this is your y equals ax squared, where it is up like a cup. What would change if I flip it to down like a frown? It'd just be a negative a, and then where does the directrix go? It just, the whole image shifts. Okay? So if I take this, group it, you'll have to apologize. I apologize right now for how bad this is going to look. But if this becomes a y equals a negative ax squared, the picture just does this. Yes, I know. Because remember, your vertex, and this goes for all of our conic sections, our vertex will always open towards a focus. Okay? Your vertex will always open up towards a focus. Not too terrible? All right. Now, let's start thinking about things in terms of algebra. I'm going to go back to the generic idea. Don't worry, Mackie, it's okay. I see what you did there. I see your directrix. Sorry, I'm bad. How do I solve for x? You know what? Let's do this first. Let me do this. Let me just say, let's just say y equals, let's just say our a value is 1 for right now. Okay? Square root. Now, if you take a square root over an equal, what do you have to do? Plus minus. So if I do that, I'm going to say that y plus or minus square root of y is x. Okay. Now, let me see how I can show you this without drawing it up too crazy. That's not going to work. All right, let me do this one then instead. What happens if you have something like that? What? No, let me just ask you. What happens here? What do you think that looks like? Well, if an x squared parabola opens up and down, what do you think a y squared parabola goes? So this is going to be your so a y squared parabola, a y squared parabola will open up either left or right, depending upon its a value. If your a is positive, which way do you think you're going to open? Correct. And why do you think that? Correct, and that's it. And it's quite literally that. Okay. So if your a value is positive, it's going to open towards the right because you're right. That's the positive direction. If the a value is negative, you're going to open to the left. Correct. SMRT. Now, same deal goes for, it still has a vertex, it still has a focus, and it still has a directrix. Now, this distance from here to here is always going to be the same. You guys remember how we mark congruencies? Bless you. One of the things that I do a lot of times with conic sections is I don't, because we're usually walking, we're always going to walk horizontal and vertical lines to get to our focus, directrix, co-vertex, and all that kind of fun stuff. A lot of times what I do to show the congruency, instead of just marking the straight line tick mark, see how I put that little curve? Sometimes it's a little bit easier to see where the congruency is by doing that. Believe me, when we get into marking up ellipses and hyperbolas, you'll really understand why I do that little curvature to it. It just keeps the picture clean. That's really the only reason I do it that way. Right? If my directrix is moving up and down, what's the equation of every single vertical line? X equals a number. So the directrix for a y squared parabola will always, always, always be x equals some number. Whereas the directrix for an x squared parabola will always be y equals a number. The reason being is because that directrix wants to slice through both arms, if you will, of the parabola. It's kind of a weird way to think about it, but that's kind of the easiest way to do it. All right. Not terrible so far. All right. So let me show you how they work with these things in terms of values and how you find parts. So, excuse me. Just wait. Just wait. Within every single parabola, this is not changing from what you already know. This does not change from what you already know. If I have an x squared parabola, in order for us to figure out where the focus and where the directrix is, there's going to be an equation to do so. Now, earlier, we would say that this was x squared equals a times y. Or we'd say ax squared is y. What they're doing is they move things around a little bit to isolate the x squared. That's what they're doing. They're just isolating the variable. This value that's in front of the y, we're going to call it 4p. So what happens here is, for us to be able to identify where focus is and where our directrix is, we have to just look at what the coefficient of y is. It's a super easy way to do this. Today, remember, everything is centered at the origin, so all of our vertices are going to be at 0, 0. So you don't have to worry about any of that. All you have to be able to worry is if you're going to count upward for focus, downward, left, or right. It's always weird when I do the opposite. Okay? For example, if I say I have an x squared parabola equals 8y, and I want to graph that and identify where my vertex is, where my focus is and my directrix. Because I know where my vertex is, it's at 0, 0. So if I want to do that, and I want to plot and get a rough idea of what that looks like, here's what we do. First of all, is it going to open upward or downward? Why? Because it's positive. Good. So what we do here is we know that this is going to open upward. And I know that in this case, what does the 4p have to equal? what does the 4p have to equal? You're stepping ahead of me, but you're right. It's going to have to equal 8. You solved for p already. I was just trying to show the initial step. You're correct, but I just wanted to show everybody where does that come from. What we're doing here is we're taking this value in front of the y value. We know that it's going to be 4p equals 8, which means your p value is, like you said, Caleb, 2. So that means that my focus, when I graph this, there's my focus. My directrix is going to be to the other way. What's the equation of that horizontal line then? y equals -2 because it's the opposite direction. And your parabola goes like this. Yes, sir. In my brain. Example. Sorry, I didn't write that down. I just thought of a quick example that would be really easy to show. To show you guys that really what we're going to be doing here is you're going to be given a value, just like that and that. And then we're going to be able to set that, find out what that p-value is, to identify how open, how far it's going to wide up or whatnot. I'm not even worried about how wide the parabola itself is opening. I really don't care at this point. I'm just worried about what this looks like. Not so bad? Okay. Does it change if I flip-flop to a different type of parabola, a left or a right? No, we're just walking different directions. Remembering, well, here, let's write this out first. You get this generic form for parabolas. You're either going to have an x squared equals a 4py, or a y squared equals a 4px. If it's an x squared parabola, it's going to move up or down. If it's a y squared, it's going to move left or right. So it's going to be an up or down, left or right. One of the quick, easy things to remind yourself of is if it's up, you know it's positive. If it's down, it's negative. But you guys know that. That's not a crazy thing. For right now, our focus, since everything is centered at the origin, our focus is going to be at 0 and whatever your p-value is for an x squared parabola. Your directrix, bless you, your directrix is always going to be at y equals the opposite of p. So if my p-value happened to be -6, means it's opening downward, my directrix would be at y equals 6 above it. That's how that works. They're just always going to be opposite. Because that distance from that vertex to the focus has to be identical from the vertex to the directrix, because it has to stay balanced to make it work. If they're not balanced, then you're, just like we said, it's like walking around without your glasses on. You don't see so well, do you? No. Now, if I... You see that well with the bucket? I was trying to draw. He says, I don't see that well. Now, did you see this well? Because there's a bucket with a well. Oh, I tried. And then the... I know, right? I need this whole wall to be a smart board. That'd be awesome. Write a grant for me, would you? You betcha. I sense sarcasm. You like this? I did. I wrote a grant. Anyway, axis of symmetries. Remember, when you have an axis of symmetry for this stuff, it's still the same idea. It's going to be the x-coordinate of your vertex for when it's up and down, or it's going to be the y, or the y equals, in the other case, it's going to be the y equals 0. So It'll be super, super easy to figure out how it works. We're not going to worry so much about axis and symmetry stuff today at all. We probably won't even notice that until we get into shifting stuff in about a week. Okay? So, graph paper is not fun. Let's look at this. X equals negative 1/6 y squared. And I want to graph it, identify the focus and the directrix, because we know where our vertex is. Our vertex is going to be where? 0, 0. Okay. What's that? What do you think? Yeah, what do you have? Our generic form, remember, our generic form for all these things is going to be y squared equals 4px. So I wanted to make it look like that. Okay? I always want to make my equations look like that, whether it's an x squared or a y squared. I know right away it's going to be a y squared because there's a y squared. Convenient. Okay? Parabolas are the easiest ones to identify what direction they're going. As we get, well, circles are pretty easy too. In a roundabout way. Sure. Anyway, so it wasn't funny. What do I do now? Multiply by -6 to both sides? And is it okay if I put y squared on the left-hand side there? Are we all right with that? The reason that I do that is that way it fits the same generic formula that they normally use. So I'm just going to say that y squared is equal to -6x. So that means, what do I have to set equal to figure out p? I have to set, -6 equal to 4p. So 4p equals -6, which p is -6 over 4, otherwise known as -3 halves. Yeah. Which way is this moving? It's moving to the left. Very good. So we know this one's going to open to your left. Y squared. Our vertex is at the origin. My p-value is -3 over 2, which means how far over I go? -1.5. So 1, 2, and there's the middle. Where does the directrix go then? So I'm sorry, I've got to label this here real quick. This is at my focus is at that -3 over 2, 0. And then my directrix has to be the same distance from the origin to the left as it is to the right then. Yep. And then the directrix is a line. What's the equation of that line then? It's vertical, so it's going to be what equals a number? And what the other way? Yeah, it's regular, 3 halves. And it's open like this. And for now, that's all we need to know how to do. And that's what we're looking at being able to do. You all voted all the. Sorry. And I never felt this way before. I swear, it's the truth. I know it's bad, isn't it? Try one more. That's not 7.8y squared. It's not 7.8. It's Remember, you want it to look like, you want to get to y squared equals 4px. So my suggestion to you guys is to automatically write down the generic form of the equation that you're going to eventually use. Okay. Am I going to make you memorize all of the equations?
Yes.
No. Will you have to know how to use all the parts? Yes. I will give you guys all equations. Obviously, we're starting with non-shifted stuff. When we get to the shifted stuff, it'll look like that, where you have an H and a K where you're moving things up and down. I will give you all of those formulas, and it's just matter, you still have to just know how to use the parts. When they shift things, it's still going to be the same distance. Vertex to focus, focus to directory, or all those things all work the same. You're just moving it in space, and it's counting differently. So in this case here, what do I do to move the 8? Slide over, so I'm going to get, in our case, it's going to be y squared equals 1/8 x, which therefore means, what do I set equal to 4p? 1/8, yeah. So 4p equals 1/8. So multiply by a fourth, a little bit easier to see it that way. So my p-value is at 1, was it 32nd? Okay. How do you graph that? No, how do you graph that? Well, what direction is this opening? Ooh. The positive direction, very good. Which positive direction? Narrow it down. You got 2 to choose from. This has to move to the right. We know it's going to go and do this. My vertex is at the origin. My focus will be then located 1/32, comma 0. Does it matter where I put it? Not necessarily, because here's the thing. If I say that it's about that far from the vertex on the right-hand side, how far over should I put my directrix? About the same-ish. And the equation of that directrix then is, well, is it x or y equals? X equals, very good. And then it'll be at x equals negative 1/32. And it's okay. It's not drawn to scale. It doesn't have to be. Right? We're just getting a visual representation of what something looks like to be able to identify parts. Because I know that distance from the vertex to the focus is 1/32. The distance from the vertex to the directrix is also 1/32. Not terrible? Maybe. All right, let's go backwards. Write the equation in standard form with the vertex at 0, 0, and the given directrix. Okay? Write the equation of the vertex of the equation in standard form of the vertex at 0, 0, and the given directrix. Very good. Very good. Our vertex in this case is where? 0, 0. The y equals 2, is that above it, below it, right of it, left of it, right of it? It's above it, isn't it? Because it's y equals 2. So if that's y equals 2, what direction does this have to open? Downward. If it opens downward, is it an x squared or a y squared? It's an x squared. So this is an x squared parabola. And our p-value, well, our p-value in this case, since it's opening downward, has to be negative, doesn't it? Okay. How far is this to the vertex? 2. So what's your p-value? There we go. So x squared equals negative 8y. By knowing, what we're doing here is, notice again, I made a quick visual, knowing that my directrix is above the point. That means the graph has to open downward. It is always opposite. The directrix is always opposite the direction it would open, because remember, the directrix, it wants to hit both parts. The directrix will hit both parts if it fell. or moved. Okay? It won't hit this way if this is turned over here. It would only touch it in one spot. It wants to touch it in two spots as it falls through. That's kind of like the little trick there. Yes, ma'am. It's a balance point. It's what happens. It's like think of it as like a teeter totter. The way that parabolas work, you're in physics, right? So have you gotten to light stuff yet? Right. You should. Well, you know how refraction occurs with mirrors and stuff like that. It's kind of the idea here that there's a certain balance point that happens behind it for it to reflect and come out. That's where it comes from. It comes from that whole idea of that. It's kind of weird to think of, but that's what we're looking at. So I know this is totally different, but really it's like a one-step equation after. It's like every other. It's like 15 problems. Actually, let me see what I know about that. Was it? That does seem like a lot of problems. Do that, 3977. So it's still every other odd. There's a handful of graph them. When you graph them, don't use graph paper. Just use a little small section, but still identify it. Where's your vertex? I'm sorry, your vertex is always at 0, 0. Today you don't have to write that out. Eventually you will be writing it out all the time. But for today, all I want you guys to do is label where's your directrix, x equals a number, y equals a number, and where's your focus for the graphing parts. And then the other ones, the other half of the problems are write the equation. You'll be given a directrix or you'll be given a focus. Again, it's super easy to just draw a small graph to identify what direction things are going. Remember, parabolas always open to the focus. All right? We'll do circles tomorrow.